From the beautiful studios of Way Happy, this is Mr. Meyer in 10.5 parabolas. Now, parabolas are super important. The definition right there that you see, the set of all points equidistant from a line called the directrix to a point called the focus, and the focus super, one of these things we're going to talk about a ton probably, is what the definition of a parabola is. You've done parabolas. You've always done these y equals, x squared parabolas, and those have been great. But let's now talk about how a parabola is even created. It's this magic point called the focus and this line called the directrix right here. Now, every point, CP1, CP2, those guys are the same distance from the focus as they are the directrix, right? So those lines are equal, or to use a little bit of your geometry notation, like I could put a little tick mark here and a tick mark here to let you know they're the same, or 2 tick marks here and 2 tick marks here, to let you know that those distances are the same. And that's true everywhere on the parabola. All right, so that focus is very important. It's very common shape. If you've ever used a flashlight, right? Your flashlight has a parabola right here, and there's the light bulb sitting at the focus. And then when you turn that flashlight on, when you click it on, all the light comes out. And what happens, it's at the focus, so it all comes out and it bounces off the parabola and then shoots straight out. And that's why you get this beautiful beam of light. Or at my house here, I have DirecTV, and it has a parabolic antenna, and they put right here at the focus, they put the receiver. And so there's this satellite up here in space, and it's flying around and it's sending down the DirecTV signal so I can watch the Sharks games. And what happens is no matter where it hits the parabola, it'll bounce off. So I get this super clear picture, right? So all of these rays come bouncing off and they hit the parabola and they get redirected right to that focus. So that's called the reflective properties of a parabola. And that's what's so crucial, is that every point on the parabola is the same distance from the focus as it is the directrix. That's the definition of a parabola. All right, let's talk about equations. The equation you need to know is right here from the Algebra 2 book and right here from the pre-calculus book, right? I prefer the pre-calc one for one simple reason, and I'll show you when we graph. But it really has to do with A, no fractions, which is what you guys like, and B, it has to do with this thing called the p-value. Now, in this equation, in the Algebra 2 one, you'll see that they leave the squared on the one side with the fraction, or the 1 over 4p. And the only difference is that the pre-calc book multiplies this over to the other side, right? It just multiplies it over. That's the only difference. And so that's why I'm going to use this one. So I'm going to use this one where they multiplied the 4p over. So it's really easy to remember. When you do a parabola, get the squared thing on one side and everything else on the other. So whatever's being squared, you want to loan on the left side, then move everything over to the right. Now what'll happen, and the reason I like it is right here, is that, see this p-value, it's going to be important to us, but see how it's next to a y, and y's go up and down, and look, the parabola opens up or down. And see right here, the p-value is next to the x, and x's go left and right. Well, look, the parabola goes left and right. So it's really kind of nice to see which way things go. Easy to remember which way things go if you write it in that equation. Here's some things you might want to write down. When you have the equation parabola, again, h and k is going to be your vertex. We all know what a vertex is. That's where that parabola starts at. The focus then will be p units away. Notice it's p units away either in the y direction or p units in the x direction. So that, again, super helpful because it's right next to each other. And then there's this thing called the focal width, and there's also your axis of symmetry and your directrix, where you can find those. All right, you know me, I like to go straight to graphing. So let's go ahead and graph this. So here's my first one. I want you to find everything for this equation right here, and I took it from the Algebra 2 book, so therefore I got to clean it up a little bit before I'm going to like it. I'm going to have to multiply both sides by 8 because I want the squared alone by itself. So I'm going to have x minus 2 squared equals, and now we multiply the 8 to the other side, so 8y plus 3. All right, so that was just me moving the 8 to the other side because I wanted the squared by itself. Now there's one super weird thing that you're going to notice about this formula, is that it has a 4p, and that's because it's a quadratic, and that 4 shows up when you FOIL out the whole quadratic formula, and I can show you that in class. But here you go. What you want to rewrite this formula as is, now that you got the squared alone, you want to have a 4 and you want to figure out what p is to get you the number that you have. So in other words, this number's got to equal 4p, right? And sometimes it's going to be pretty like this one, and sometimes it's going to be nasty. And the way you figure out the nasty ones is you just kind of go, oh, well, I need to know 4p equals 8. So divide both sides by 4. So p is 8 over 4, which is 2, which is probably what most of you said already, right? But we want to make sure that you don't think that that's, if it's something gross, it won't scare you. There you go. You've now figured out the standard form and the easiest way to graph a parabola. So I'm going to get my parabola. I'm going to get my graph paper. So there it is. And the first thing I'm going to do is plot the vertex, which is a very important point. Your vertex is sitting at 2, -3. Remember to do opposites, just like every other shape we've had. 2, -3 is right there. So there's your vertex. And I'll probably write it because people are going to ask me, like, where's the vertex? So I'll tell them. Then here's the part I love about this formula. I'm going to go 2 units in the y direction. If that's a positive 2, I'm going to go up 2. If it's a -2, I'm going to go down 2. So that's why I like this. So this is a up 2. So I'm going to go up 2 to find the focus. Now remember, p is the distance to the focus, and it's in this direction. So you don't have to remember a whole lot. It's kind of obvious. You're like, oh, 2 units in the y direction. Let's see. Up 1, 2. That's going to be what's called my focus. So the focus is at the point, what is that? 2, -1. And the directrix, remember, every point is equal distant to the focus as it is to the directrix. So if we went up to the focus, then guess what? We got to go down to, and that's going to be our directrix, and that's a line. So that's the line going straight across. So the directrix is the line, what is that? Y equals -5. So it's a line, so we're going to say y equals. And now you're almost done. In fact, here I'm going to show you one more thing. That this 4p value, this right here, is what we call the focal width. And the focal width is just how wide the parabola is at the focus. Now, you know this parabola goes something like this, right? You know it goes blah and blah like that. But you don't know how wide it is, so we need to figure out a good way to figure out the width of it. Well, the super best way is to take what's called the focal width. You go to the focus and you make it that wide. In this case, 8 units wide. So that means 4 to the left. 1, 2, 3, 4. And 1, 2, 3, 4 to the right. That's the focal width. It's 8 units now, which is what it's supposed to be. And now I can make my beautiful parabola like this. And that, my friends, is how you graph parabolas. What were the things we did? We found the vertex. Then we did the 4p because p is the distance to the focus. Then we did the opposite because that's the distance to the directrix. And then last but not least, we did the focal width, and we graphed ourselves a beautiful graph. Now, we will try that in class. So let me ask you a question, and we'll come right back. All right, nice work. Now, here's where it's going to get a little tricky. I'm going to give you a graph, or in part B, you can see, give you some information, and you tell me the equation of the graph. So you're going backwards. So that last example, we graphed an equation, and now we're going to have a graph, and we're going to make an equation. So the one thing you want to know is your brain's got to go, all right, it's a parabola. This is either y minus k squared equals 4px minus h, or it's x minus h squared equals 4py minus k. And the big thing is to notice is, again, that p value relationship. So if it looks like the focus was going in the x direction from the vertex, then I want you to use, the top one. If it looks like the focus is going in the y direction, I want you to use the bottom one. So we come over here and we identify some stuff. We're like, all right, this is definitely the vertex right here. So I know the vertex is at 0, 0. We like it when it's 0, 0. That makes the h and k kind of easy. And I can see that the p value went down. What is that? About down 2.5 maybe, right? Oh no, they're going by some weird numbers. They're going by 2s. So it went down 5. So the p value was -5 in this case. It went down 5. Well, that means it's in the y, so I know it's equation number 2. So I know that this is x minus h squared equals 4p, because again, p went down, so that's in the y direction, so p is going to be right next to this. Well, now we're going to fill in the stuff we know. We know that p is -5. We know h and k because they are 0, 0. So here you go. X minus 0 squared equals 4 times -5 y minus 0. And most people will clean that up. X squared equals -20 times y. And there's your equation. Now, again, if I go look in the back of the book, there's my answer, right? I'm done. If I go look in the back of the book, a little heads up, they're going to divide the 20 over. So the book's going to say y equals 1/20th, -1/20th x squared. And that's fine. If you do that too, I love it. I don't care which way you go. I can figure out both of them. But just so you know, I write them as x squared equals, or, x minus h squared equals, and the book writes them a little different. All right, let's try the other one. So same thing here. I got a vertex again at 0, 0. So again, I need a picture. 0, 0. The directrix is x equals -6. So if this is the x-axis, 1, 2, 3, 4, 5, 6. That's right here. So that's the vertex, and this is the directrix, which means if that distance was 6 that way to the directrix, it's also 6 to the focus. 6, it's also here to the focus. And the parabola, opens up around it. I don't know the focal width just yet, but it looks something like that. Again, parabolas open around their focus. So if I notice that the p-value, right here is the p-value, if that p-value moved in the x direction, then I want that top equation. I want y minus k squared equals 4p x minus h. Now there's some stuff I already know. Like I know the vertex is 0, 0. So I can plug that in. That's your h and k, right? I know the p-value. The p-value looks to be +6. So I'm going to put a +6 in. So here you go. Y minus 0 squared equals 4 times 6, x minus 0, or what we would call y squared equals 24x. And again, the book would have it as x equals 1/24th y squared, right? So you could have either one of those. All right, I'll ask you a question. We'll be right back. All right, good work. Now let's get this last one done and get out of here. So example 3, I give you the focus and the directrix. So again, I need a picture. So as I sit here and I draw, I know the focus is sitting at 2, 4. So there's your focus. And I know the directrix is at y equals -4, 2, 3, 4. So that is right here. The directrix equals y equals -4. Now, there's 2 ways to do this problem. And one way is to look at the graph and understand everything that's going on. And then there's this other way that the book says of using distance formula. I'll show you both. So the first one that I'll show you is like, what the graph's doing. You know that the vertex has got to be the same distance away from the focus as the directrix. And it's got to be on this, I never even talk about the axis of symmetry, and I probably should. It's got to be on that axis of symmetry, right? Where it's the same on the left and the right. So if that's 8 units, then 4 away, then the vertex must be sitting right here. I know my drawing isn't that great, but that's got to be the vertex 2, 0. And now I already know that this thing's got to look like this. I already know the p-value is 4, and I also know that it's in the y direction. So guess what? I got the equation already. It's x minus 2 squared equals 4p, which is 4 times 4. And then what is it? Y minus 0. And done. This is x minus 2 squared equals 16y. And that's beautifully done, right? Now let's talk about what they're talking about here when they say the distance formula. Well, they do say the definition of a parabola is that the distance, any point, right? Any point is the same distance to the focus as it is to the directrix. So those have to be the same. And if that's true, I could use distance formula. Now, if you remember your distance formula, it's x2 minus x1 squared plus y2 minus y1 squared, and that whole mess square rooted. So let's try it. So we have one point that we know is the focus. That's easy. So the distance to the focus would be x minus, what are you going to call it, 2 squared plus y minus 4 squared. square rooted. That's the distance to the focus from any point. I just made up a point, by the way. The point was xy. I made it up and I made the distance to the focus. So we just found that distance, right? Now I need the distance to the directrix. Okay. So the distance to the directrix is a little harder from this point, right? Because this was the point 24. That was easy to calculate. Well, what point is this? Right? I don't know. Do I? Oh, wait, maybe I do. If that's the point that we're talking about, the x would be the same, but the y would always be -4. So the x would be the same, but the y is -4. So again, all right. So x minus x would be, oh, that's weird. X minus x squared plus y minus, plus 4 squared. And that's square rooted. So the distance, this is the distance to the focus, this first one. And then this is the distance to the directrix, right? And if you look at my drawing, should make nice sense. Now, first thing I do is I see square root on both sides. I'm going to square both sides. So now I have x minus 2 squared plus y minus 4 squared equals, well, look at that. That cancels out. That's really just 0 squared. So this is y plus 4 squared on this side. That kind of just dropped out. And so there is what I have. And now I'm just going to pretty this up by getting all the squareds on one side and everybody else on, and the x on this side. So I'm going to leave the x on this side, x minus 2 squared. I'm going to FOIL this out. What is that? Y squared minus 8y plus 16. And over here I have y squared plus 8y plus 16. I think that's what I get. Now combine stuff over. Subtract the x squareds over. Boom. Right? So add the 8y over. So I'm going to add the 8y over. And now I have the x minus 2 squared equals, oh, don't forget the 16 I had sitting here, plus 16 equals, and what am I left with? 16y plus 16. And in that last step, I'm going to subtract the 16 over. And I'm going to have x minus 2 squared equals 16y. Look at that. The same exact thing. Yeah, it was a little more work, but it shows that the distance to the focus and the distance to the directrix makes every point on the parabola, and it doesn't even matter what the point is, because I didn't really pick a point. I just called it x and y, which is some random point on the parabola, but I made their distances equal, and that's why it worked. There's your equation. You have a great day. I'll see you tomorrow. Stay happy.